So we are still going to be talking about radicals and square roots today. We're just going to add a little bit more detail to what we were doing with them yesterday. So we still want to simplify them, but now we're going to be looking at things that involve some more variables. Okay, so no new steps to write down. Video notes are going to be sort of short here as we just include what happens now if I have something like 12x to the third. And we didn't have that yesterday. We just had a straightforward number. Now we have some variables involved. Well, good news is that the rule doesn't change. Okay, so don't let this variable throw you off. So same way, we're going to start exactly the same. So we're going to start by prime factoring. And remember when we prime factored this in our factoring unit, we just started with the coefficient. So 2 and 6, 2 and 3. Okay, so we have a 2 times a 2 times a 3. And then we looked at the variable and we would write down the number of x's that the exponent was. So this would be an x, and an x. Okay, so now we're here. And then just like we did yesterday, we are now going to circle the pairs. So we have a pair of 2's and we have a pair of x's. So we're going to have a 2x that's coming out in front, right? A 2 comes out in front, an x comes out in front. And then what do we have left inside? Inside we have a 3 and we have an x and we are done. Okay, so really we didn't involve anything new, nothing's changed. We just got to get that variable prime factored and then the process plays out exactly how it did yesterday. Okay, now what happens if there's already a number in front? So let's say we have something like 3x times the square root of 20x to the 5th y squared. Okay, so this already has stuff sitting out here. But again, don't let that change your rules. The biggest mistake I see from my students is that they try and treat this as a division sign, right? This isn't division, it's a square root. So there's really a multiplication symbol happening here. It's 3x times that. So we're just gonna ignore this for a minute and start prime factoring. So 20 is 2 times 10. 10 is 2 times 5. So that's a 2, and a 5. And then we get 5 x's. And we get 2 y's. Okay, so we're now here, and we're going to look for pairs. Pair of 2's, pair of x's, pair of x's, pair of y's. Okay, so a 2 comes out in front, an x comes out in front, an x comes out in front, and a y comes out in front. Okay, and then we have a 5x left inside. Okay, now everything in the same place gets multiplied. So now we need to remember our rules of polynomials and exponents, right? When we multiply, we add. So that's a 2x squared y square root 5x. But we can't forget that there was this other stuff already out in front. Okay, and this said 3x times that. So now we're going to multiply this times 3x as well. Again, that's our properties of exponents from our polynomial unit. 3 times 2 is 6. We add the exponents. So 1 plus 2 is 3 because we add when we multiply. Y still comes along. There's just nothing to combine it with. And the 5x is just left over. So we get 6x to the third y square root 5x. So I mean, yes, they can get significantly longer, but they shouldn't be any more difficult. Okay. It's also important to recognize, I mean, I've been doing a lot of square roots in my life, but that every single square root can't be simplified. So if you get something like the square root of 42xy, you're like, okay, I'm going to start prime factoring. 2 and 21, 3 and 7. And so you go, oh, okay, Mrs. McKinney, I must have done something wrong. I don't see any pairs. Well, you just might not. It might not be able to be simplified. Now, I've tried to simplify 42 enough times in my life that I just know it can't be simplified. And so the square root of 42xy is as far as I can go. There were no pairs, so I know it's in its simplified form, and so that's the way I should leave my answer. Okay, you just kind of have to check. I don't have a perfect answer for you. The more that you do them, the more that you check, the more you'll recognize when you can and when you can't simplify. Okay, then one last one here, and you're all gonna love me when I write it down. What happens if we're given a to the 50th, b to the 23rd? And the question is, do I have to write down a 50 times? Well, you could. I don't want to write down a 50 times. I highly doubt you want to write down a 50 times. But if you absolutely are stuck and you don't know what else to do than write a down 50 times, I guess you're writing down a 50 times. However, we are looking for pairs. So how many pairs would there be if I were to write down 50 A's? And hopefully we go, oh, well, that would be 25 pairs, right? Because to find how many pairs there are in something, we're really, truly dividing by 2. Okay, so if you don't want to write down all of those variables, you can really just divide by 2. Okay, so 50 divided by 2 would mean there's 25 pairs, and we would have 25 A's coming out in front. Now then you might say, well, I can't divide 23 by 2. Okay, and here's where you're gonna have to think way back. It actually meant something. Okay, remember when you did, maybe I'll do it right over here. You did 23 divided by 2, oops, like this division sign. And you went, okay, it goes in there once, which is 2. You'd subtract and get 0 and bring down the 3. And 2 would go in there once. And then you just write down this piece. You just say remainder 1. Okay, we eventually learned, okay, that means there's a 1/2 left. But what this is telling us is that there's 11 pairs. So 11 B's can come out in front. And there's one lonely B left over. It doesn't have a pair. And anything without a pair stays inside the square root. And so our final answer here would be a to the 25th, b to the 11th, square root b.